Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you the Newton's laws of motion in one shot. There are separate videos for each topics, that is pseudo force, equilibrium of a body, free body diagram, rocket propulsion, etc. So there are separate videos for each topics. Now today I will teach you the best Newton's laws of motion for NEET preparation, for NEET exam, which problem, which topics, which theory is required, I will teach you. So student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the NEET exam confidently with a good rank. Now let's start about the class. So there are separate video on each topics, that is pulley topics, pseudo force, equilibrium of a body, free body diagram. So there are separate video for each topics. If you require, then you can watch the single separate videos. Now I teach you today in this class Newton's laws of motion in one shot. So first, what is impulse? First topic is impulse. What is impulse? Impulse is denoted by J, that is product of force into time. Force into time is called impulse. Now force equal to ma v minus u by t into t cancel, so change of momentum, that is del p. Impulse equal to change of momentum. So for constant force, if force versus time diagram is given and constant force act for t second, then we can see that then force into time is area of, so area of a t diagram is impulse. Now for variable force, so for variable force, f is given as the function of t, so impulse equal to formula is f dt for t1 to t2, that is f t dt t1 to t2. For variable force, this is the formula of impulse, is given as this is the force is given in the function of time. Find impulse or change of momentum, for first 3 seconds. So how can you do it? Impulse equal to, apply this formula, 0 to 3 f dt, which is equal to f dt, which is equal to what is the unit? Unit is force into time, that is Newton second. This is the answer. So that is impulse equal to change in momentum and force into time. Suppose x versus t graph is given, x t. Suppose this is x is in meter, this is suppose 6, this is 3, this is 6, this is in meter, this is in second. Find impulse at 3 seconds of body of mass 1 kg. That is, find the impulse of the body of mass 1 kg, whose xt graph is given, x versus, that is distance versus time graph is given. Now at 3 seconds, what is the impulse act on 1 kg body? So this is the problem. Now we know impulse equal to change in momentum. So here we have to calculate the velocity, initial velocity and final velocity, final minus initial. So this is the answer, mass equal to 1. What is final velocity? Final velocity at 3 seconds, that is when at 3 second, right side slope of xt graph is the final velocity and slope of this graph is initial velocity. What is final velocity? Slope of this graph will be negative slope. So negative slope, that is 6 by this gap is 3, that is slope of this line. You know that slope of xt graph is equal to velocity. For each topics there are separate videos. If you are weak about the theory, then you can watch my separate video which are made specially on each topics. So you can watch the video. Now final velocity equal to slope of xt graph, which is equal to 6 by 3, that is 6 by 3. This is negative slope because this is negative angle, minus initial velocity is slope of this graph, that is 6 by 3. So this is the answer. Now magnitude is 4. So this is the impulse. Okay. Next, free body diagram. How can you draw the free body diagram? So to solve the problem, suppose this type of problem, suppose M1, M2 and M3, three blocks are given side by side. What is the contact force between M1 and M2 and M2 and M3? What is the contact force? So for this type of question, you have to draw the free body diagram. Draw the free body diagram. This M1, M2, M3. Okay. Now a force is given. Force is given to the left side. What is the contact force between M1 and M2? Force is given. So you have to draw the free body diagram. That is, draw the body separately. Now show the different force acting on the body. So what is the force? Here force F is act in this direction. M1 push M2 with a force R1, M2 push M3 with a force R2. Now if this is action, that is reaction, and this is reaction, R2 R2. So for each contact phase, for each contact surface, there is an equal and opposite reaction. This is action, this is reaction. Fine. So this is acceleration A. Now write the equation of motion. F minus R2, sorry, this is R2, this is R1. Okay, R1. F minus R1 equal to M1A. This is now for this for the block M2, what is the equation? Equation is R1 minus R2 equal to M2A. And for the block M3, what is the equation? Equation is R2 equal to M3 into A. So if you add 1, 2 and 3, then you get the acceleration A equal to F by M1 plus M2 plus M3. Now if you put A in 3, you get R2, which is the contact force between M2 and 3, and if you get A in 1, you get the R1, which is the contact force between M1 and M2. So to solve this type of problem, you draw the body separately, then you show the what the different force acting on the body, and write the equation of motion. Equation of motion is always resultant force equal to mass into acceleration. So this is the resultant force. So here resultant force is F minus R1, which is equal to mass into acceleration. Here resultant force is R1 minus R2 equal to this. Here this. Here a block of mass M is present, length L, and at end F1 is applied, at this end F2 is applied. Now what is the contact force, or what force act at a distance x from this end? That is the end at which force is applied. What is the question? What is the contact force? Here you have to find contact force or reaction force. Reaction force at a distance x from this end. So to solve this problem, what is the solution of this problem? To solve the problem, you have to draw the free body diagram of each section. You have to draw free body diagram of each section. Now this is the length x. So what is the length of this? Length of this is L minus x. Now what is the mass of this and this, you have to calculate the mass m1 and m2. How can you find mass? That is the body is uniform, so mass per unit length, that is mass per unit length is constant throughout the rod, throughout the block. So what is the length of this x? So mass per unit length into length equal to m2. What is m1? m1 will be similar way l minus x. So you find m1 m2 mass per unit length. For unit length mass is this, for x length mass is this. So you can find m1 m2. Now draw the free body diagram. What is the free body diagram? Here force F1 act, and here suppose the contact force R. If this is action, this is reaction, and F2. Now if F1 greater than F2, suppose F1 greater than F2, now whole body moves in this direction A. Now you can write the equation of motion. The body moves in this direction, so R will greater than F2. R minus F2 equal to m1a. This is equation 1. Here F1 act in this direction, R in this direction, F1 minus R equal to m2 into a. This is equation 2. Now if you add, you get 1 and 2. If you add 1 and 2, you get F1 minus F2 equal to m1 plus m2 into a, which is, for this you get a equal to F1 minus F2 by total mass. m1 plus m2 is total mass, so you get this. Now if you put a, you have to find the R, okay, R. So if you put a at here, equation 1, you get R. So from equation 1, R equal to F2 plus m1a, which is equal to F2 plus m1. m1 is this into a is this. So this is the answer. So in different form, f1 into 1 minus x by l plus f2 1 minus plus this into x by l. So this is the answer, this or this. So this is the contact force, okay. This is a wall. Now one question in impulse, this is a wall. So if a body, if a ball moves with velocity u, if a ball moves with velocity u and rebounds with same velocity and the ball makes an angle, this angle is suppose theta, this is theta, same angle. Now find impulse of the ball, or if the time taken, if the time of contact is given, find the force exact on the wall. Find impulse of the ball, or if here time is given, t contact time, if contact time is given, find force exact on wall. So this is the question. A ball of mass m, mass is given. A ball of mass m strike the wall with velocity u at an angle theta with vertical and rebounds with same velocity. What is the impulse of the ball? And if the time of contact is t second, find the force exact on the ball or on the ball. So to solve the problem, what is the impulse? Impulse equal to change of momentum. Impulse j equal to change of momentum del p, which is vector quantity. Now del p equal to m. If the body moves with same direction, then we can simply subtract the two values. But this is the this angle, the direction here are different, so we cannot simply subtract the two values, because this is the vector quantity, so we have to subtract vectorially. Now what is the final velocity, final momentum? final momentum equal to mv minus initial momentum equal to this. Now mass velocity, final velocity, what is the velocity final? This. Now vectorially we can, so if this angle is theta, then this angle is theta, so this is u cos theta and this is u sin theta. Again this angle is theta, so this is u cos theta, this is u sin theta. So final velocity equal to, vectorially we can write, if we take this direction is I and this direction is j, then final velocity in terms of vector mu sin theta I plus u cos theta j minus, this is final velocity, initial velocity is u sin theta minus I plus u cos theta j. So the u cos theta cancel, so this is equal to 2m u sin theta I. Okay, this. Now magnitude of the impulse equal to 2m u sin theta. This is the answer. Now what is the force? If you are asked to calculate the force equal to impulse by time, rate of change of momentum of time, mu sin theta by t. So this is the answer. Suppose here a 8 kg block and here a 10 kg block are connected by a string of length, string of mass. This mass is suppose 4 kg. Now these are pulled with a force 200 Newton, 180, 14, 22 Newton. So suppose this 300 Newton. Now this system are pulled upward with a force 300 Newton. What is the reaction or tension at the middle point? Suppose this is middle point, midpoint. So question is here, find tension at midpoint of string, or at this connect point. Suppose this is point A, this is point B, this is point C. So find the tension at midpoint, that is point B and at point A. So what is the solution of this type of problem? Draw the free body diagram. Simply draw the free body diagram. If the whole system is pulled upward with a force this, then what is the free body diagram of this type of problem? 10 kg block, to solve the problem you have to draw the free body diagram like this way. So here 300 Newton act, weight of this block act in this direction. What is the weight? Weight is equal to mg, that is 100 Newton. Now a tension act at this point, which is T1 and this is T1. So I write, so this is T1, this is T1. Now weight of this block 2 kg, 4 kg is 2 kg, 2 kg, this is 2 kg block, 2 kg string, this is 2 kg string. Now weight of the string, that is 20, act in this direction. Now also here a tension act in this direction, T2. Now weight of the block or string always act through the center of gravity, So weight always act through the center of gravity. So see the weight always act through the center of gravity. So 20 Newton act in this direction through the rod. This is T2, this is 20. So and this is 80. Now here also tension is present. Suppose this tension is T3 and this is T3. So for every contact point there is an equal and opposite tension. Now the whole system moves with an acceleration, suppose a a a. Now you can draw the free body diagram. You can write the equation. What is the equation of the block? This equal to 300 minus T1 minus 100 equal to m into a. This is equation 1. Now what is the equation of this? T1 minus T2 minus 20 equal to m into a, 2 into a. What is this? T2 minus 20 minus T3 equal to 2 into a. Now what is this? What is the equation of this? This is T3 minus 80. T3 minus 80 equal to m into a. So if you add the whole equations, T3 cancel, T2 cancel, T1 cancel. So 300, that is 200 minus 40 minus 100, 200 minus 120, that is 80. 200 minus 120 equal to 80. 80 equal to 12, 22a. So we get acceleration we get. Now you have to find D point, that is T2 and A, tension at A, that is T3. You have to find T2 and T3. So you get T2 and T3 you get from last equation. T3 equal to 80 plus 8 into A. This is the T3, and T2 you get from second equation, first, second, third equation you get T2. T2 equal to 20 plus T3 plus 2 into A. So you put here T3, here you get T2. So just draw the free body diagram. Now for vertical upward motion, tension act at different section, and also a weight act through the center of gravity towards back. So pseudo force cannot realized by inertial frame of reference. Pseudo force can realized by non-inertial frame of reference. Now what is the different weight on lift? Different weight or different apparent weight, different apparent of a man in a lift. So a person, if the lift accelerate with a, then mg act in this direction and the lift moves upward with an acceleration a, so pseudo force act opposite direction. So reaction will be R equal to m of a plus g. Now if the lift moves downward, with an acceleration a, so weight act in this direction, pseudo force act in this direction. So reaction R will be R plus ma equal to mg. So R equal to mg minus a. So when the lift moves downward, then reaction force will be less, that is apparent weight will be less, and when it moves upward, then reaction force is more, that is apparent weight is more. Now if the lift moves with constant velocity, that is no acceleration, then R equal to mg, so R is the apparent weight of the man, in the lift. Now if the lift so what is the reading pseudo force? Now what is the reading of weighting scale weight machine which is fitted, which is attached in a lift, in an elevator, reading of weight machine attached in a elevator. That is, suppose this is a system, this is an elevator and pulley, suppose in this system, suppose elevator is moved apart with acceleration a, and two block m1 m2 are given to the two mass m1 and m2 are attached in a pulley. What is the reading of the scale? What is the reading of this scale? What is the reading of the scale? So what is the reading of scale, this scale? So the reading will be actually here tension T, here tension T, so reading will be 2T. Reading of this scale equal to 2T. Reading of this scale will be 2T. Now to find the tension, here extra acceleration is given. Now if the pulley is fixed, what is the tension? So draw the free body diagram. If the pulley is fixed, draw the free body diagram. This is M2, suppose M2G act in this direction, tension T, M1 G T. So if the pulley is fixed, that is acceleration equal to 0. What is the, now this moves suppose with acceleration A, another acceleration suppose F. So if this move with F, this move with upward with F, so equation is M2G minus T equal to M2F, and this T minus M1G equal to M1F. Now what is this? F equal to M2 minus M1 G by M1 plus M2, M1 plus M2. So this is the acceleration. Now put F equal to, here you get T, so T equal to M2, T equal to M2 into G minus F, F equal to this. So here T equal to, we get 2 M1 M2 G by M1 plus M2. So T equal to this, Now reading of the scale is 2T, so 2 into this. So reading of scale equal to 2T, that is reading of scale will be 2T. But if the here T equal to, we get this, but this is the tension when pulley is fixed. When the pulley is fixed, now whole system is moved with acceleration A. So here tension, actual tension will be G plus A, that is extra mg and ma pseudo force act in the opposite direction. So m2a m1a, if you this m2g plus a, here will be m2g plus a. Now if you calculate, what is the result? Ultimate result will be 10. You easily calculate when a equal to 0. So first find the tension with acceleration equal to 0 of the, with taking acceleration of the pulley 0. Now if the pulley moves with acceleration a, then just you put here g plus a. So this will be more convenient. First find the tension taking acceleration of the pulley is 0. Now the final answer will be g plus a, as the pulley moves, as the elevator moves with acceleration a upward. So answer will be this. Now if the elevator moving downward with acceleration a, then the answer will be g minus a. So reading of the scale will be 2T, which is equal to this. Okay. Now next topic is equilibrium of body. So for equilibrium of body we take that's net force. What is the condition of equilibrium? If the body has no acceleration, that is no linear acceleration and no angular acceleration, then the body is in equilibrium. If the body has no acceleration, so for no acceleration, summation of F, that is different force acting on the body. If total force F1 act in this direction, F2 act in this direction, F3 act in this direction, F4 act in this direction, so summation of all the force will be 0, and so this, if summation of F equal to 0, this will not produce any type of linear acceleration. For no linear acceleration, summation of force will be 0. From this we get summation of Fx equal to 0 and summation of Fy equal to 0. From this we get this, because F equal to vector sum, so because F equal to Fxi plus Fyj, so from this must be 0 and this must be 0, so we get this. And for no angular acceleration, torque must be 0. What is the torque? Torque equal to force into perpendicular distance. This is torque. Torque equal to force into perpendicular distance. So for each topics there are separate video details have been discussed in single separate video. If you cannot understand this, then you can watch my single video. Okay, you can watch my single video, separate video on each topics. So torque equal to 0 means force into perpendicular distance 0. So this is the condition of equilibrium. Now is present and a body is attached by this string, attached by two strings. Suppose this angle is theta1, this angle is theta2, and mass is m. What is the tension of each string? Tension of each strings, that is T1 and T2 find. So here we can first resolve tension in x and y direction, this and this, horizontal and vertical direction. So if this is angle theta1, so this is theta1, so this is T1 cos theta1, this is T1 sin theta1, and this is T2, so this is theta2 in this direction, D2 cos theta2, and this is T2 sin theta2, and weight act in this direction. So from summation of Fx equal to 0, we get this equal to this, that is T1, and from summation of Fy equal to 0, we get T2 cos theta equal to this. Solving this 1 and 2, we get T1 and T2 separately. So to find T1 we put T2 from this, T1 sin theta 1 by sin theta 2 into cos theta 2 equal to mg. Now you can take common T1, which is cos theta 1 plus sin theta 1 cos theta 2 by sin theta 2 equal to mg. So from this you get T1. Now if you get T1, then you can find T2, put here, you get T2. So now for particular this problem can be solved by Lami's theorem. What is the Lami's theorem? Lami's theorem is applicable for three concurrent force. Lami's theorem for three concurrent forces. So what is the Lami's theorem? Suppose F1, F2 and F3 three concurrent force act. If the opposite angle of F1 is theta 1, F2 is theta 2 and F3 is theta 3, then Lamè's theorem is F1 by sin theta 1 equal to F2 by sin theta 2 equal to F3 by sin theta 3. That is force by its opposite angle. Take the sign of opposite angle. So now if we apply the above theory, so this is T1, this is T2, this angle is theta 1, this angle is theta 1 and this angle is theta 2, weight is mg. So if we apply this theory at here, we get this is, so this angle is theta 1 and this angle is theta 2, so total angle is theta 1 plus theta 2. Now this angle is, we take we have to calculate this angle is, this is theta 1, so this angle is, this is theta 1, so this angle is 180 minus theta 1. Now this is theta 2, this is theta 2, so this angle is 180 minus theta 2. Now if we apply this theory, so T1 by this angle, T1 by opposite angle, that is this angle, sin 180 minus theta 2 equal to T2 by sin 180 minus theta 1 equal to mg divided by sin theta 1 plus theta 2. So from this we get T1 and T2. T1 equal to sin 180 minus theta 2 equal to sin theta 2. So mg sin theta 2 by sin theta 1 plus theta 2, and T2 equal to okay, now T2 equal to mg sin theta 1 by sin theta 1 plus theta 2. So this is the answer. By using the Lamè's theorem, you can solve this problem. Now what is the tricks on pulley system and constraint equation. Tricks on pulley system and constant equation. Suppose, so there is a single video, separate video on tricks and pulley system. Two videos are there. Just for NEET purpose, just I will discuss what is required for NEET exam. I will discuss now. Suppose this is a rod, and this end is moved with velocity, suppose 40 meter per second, and when this angle is 60 degree, what is the velocity of this end? Now to solve this type of problem, suppose this is one question. Second question, suppose this, suppose this angle is theta 2 theta. So if this string is pulled downward, what is the velocity, upward velocity of this block? This, and many questions are given in this type of question. And for some, if this block moves with the acceleration a1, what is the acceleration of this block? So this type of question uh, we use the theory that summation of t dot velocity v equal to 0. We use this theory that is tension and dot product of tension and velocity equal to 0 for whole the system, or t dot v t dot a equal to 0. That is total work done in this type of question where no external force is applied. This is a system, here internal force is applied, no external force is applied, so total work done, this equation comes from total work done will be 0 of the system, because this is force. Total work done means summation of f into x equal to 0. So if we derive x, f is tension, and x, if we derivative with respect to t, then x becomes v, double derivative by double derivative v by double derivative by another derivative v becomes a. So apply t dot a equal to 0, summation of t dot a. If you find that, if you are asked to find the acceleration, then you use this. If you are asked the velocity, you use this. Now if we apply this equation at here, what is the tension? Here the rod tension will this and this. So at this point, what is the angle? Angle is tension and velocity. Angle between tension and velocity is 120. So t into v is 40 into cos 120 plus here t in this direction, t into v into this angle 90, this is 30 degree, so cos 30 degree equal to 0. Now t cancel, so v equal to minus 40, cos 120, value of cos 120 is equal to cos 120 equal to actually cos 180 minus 60, which is equal to minus cos 60, that is minus half. So cos 120 is equal to minus half, that is this, by cos 30 equal to root 3 into 2, root 3 by 2, so 40 by root 3. So this is the velocity. Just apply t dot v equal to 0 for every equation. Now here, what is the problem? Tension t, this is single string, so tension t everywhere is same. Tension t tension of the string everywhere same. So if we apply this theory, then here this point, this is t at here t, the block here t, so this is t, so direction of t is this. Now from this apply t into u, here t u in this direction, t in this direction, so angle is 180 degree, cos 180 degree, plus here t velocity in this direction, so t into v into cos theta, because total angle is 2 theta, half is theta, cos theta, and if here t into v into cos theta, and here t into u into cos 180, this is 180 because u is here, t is here, cos 180 degree equal to 0. So if we apply 2t u cos 180 is minus 1 equal to minus 2 v cos theta, cancel 2t, so u equal to v cos theta, that is v equal to, we have to find v equal to u by cos theta, so this is the answer, v equal to u by cos theta, not u cos theta equal to v, not u cos theta equal to v. Students generally make mistake that this is u, so this is u cos theta equal to v, not this. Actually v cos theta equal to u, relative velocity along string. There is another method, that is relative velocity along the string will be same. So that from that we also get this relation. Now this theory is applicable for every system. Now if we apply this t dot v here, acceleration, suppose uh, velocity and acceleration both is same, both if we find the velocity then we apply this. If you are asked the find the acceleration, then just take t dot a equal to 0. Suppose here you have to find the acceleration a2 and a1. So if we apply this, so here this is tension t, 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 t. Tension is everywhere this. Now weight act in this direction, so tension act in this direction. Now t, t. So apply this theory t dot a, here t in this direction, acceleration in this direction, t1 a1 cos 180 degree plus t a2 cos 0 degree plus t a cos 0 degree equal to 0. That is 2t a, this is acceleration a2, 2t a2 cos 0 degree equal to 1 equal to tension is same along the whole string. So 2t cos a2 equal to t a1 cos 180 is minus 1, cos into minus 1, so cancel t. So a1 equal to 2a2. So a1 equal to 2a2, that is a1 is double of the acceleration a2. So this way we can find the acceleration. So many problems are given my video, on the topic sticks on pulley system and constant. You can watch this video, you get more and more problems related. You can get more and more problems about this type of problem. You can get more problem related to this type, related to constant equation. So you get more problems related to constant equation and pulley systems. Now so for rocket motion, for NEET purpose, you remember this. There are different separate chamber. One chamber different instruments are given, and another chamber fuel is kept. So fuel, which is fuel exhausting gas moves ejected with some velocity which is u. Suppose u equal to velocity of ejecting ejected gas which is constant. Velocity of ejected gas is constant. We know total, if the m is total mass of rocket at a moment. Now we know total force required will balance the weight of the rocket so that rocket can launch. So to launch the rocket, this, that is gas is ejected with a high speed and exert a force on the air. So the air reaction act on the rocket will launch upward. The reaction on the rocket which can lift the rocket upward. So what is the reaction? Reaction on the lift is by air is equal to weight of the rocket. To launch the rocket, this must be this. So what is the reaction? We know force equal to rate of change of momentum d by dt of m into u. Now m into here mass of the fuel remain constant, and here u remain constant. Here u, that is velocity of ejected gas, is remain constant, e into dm by dt equal to mg. solve the rocket motion. To solve the problem related to rocket motion, just apply this equation. Here is velocity of ejected gas, m is total mass of rocket at a moment, and dm dt is rate of ejection, which is unit is kg per second. That is, gas is ejected at the rate of this, at the rate of 20 kg per second or 1000 kg per second. This is dm by dt. So velocity of ejected gas is this. What is the weight of the rocket? Just find just to solve the problem of the rocket, just memorize this formula. U, what is u, what is dm dt, what is m are given. Just use to put here, you get the required answer. Student, this is the end of the class. To continue the best course, subscribe my channel. You get it. Very important NEET problems are discussed in different videos, and NEET theories also discussed in different video. To so to get such type of video, subscribe my channel. Okay.